will be xi plus yj. If it's a 3-dimension plus ck. This is a vector r. What is a vector r? If we have a coordinate system, and this is the position of the object in 3 dimensions. So my vector r in 3 dimensions will be given by the x-coordinate, assuming that this is the x-coordinate, the y-coordinate, and the z-coordinate. So that will be the in 3 dimensions. So this is in 3 dimensions. My vector r, which is called position vector, or sometimes called radius vector, but position vector. If we move, if this vector move from this point to another point, this will be RO, and this will be R final, which is just R. And the subtraction of R minus RO is what we call the change in position delta R. So delta R is the same than R minus RO, change in position in 3 dimensions. So if we have vector RO, or that is XO, YO, and Z, when we subtract, will be X minus XO, same thing that delta X I, plus Y minus YO, same thing that delta Y J, plus C minus CO K, and this will be your displacement vector or change in position. Displacement in 2 or 3 dimensions, or change in position in 3 dimensions. So if it's 2 dimensions, only will be up to here. Change in position. Okay, so this is just the vector, the subtraction of this vector. So if we do the tail to tip, you can see that if this is R, then if this is RO, instead of being in this direction, RO in this direction, so this is R and this is RO. So, but negative RO is in this direction, and then delta R will be from here to here, which is this. This is how you subtract the vectors. So basically, that is the change in position from A to B, from a point to another point. All right, this is what we call change in position. So instead of here, we do it only in 1 dimension. Now, you just need to get the change in position in the 3 dimensions. Same thing. You can work separately. You can get the X, the Y, and the Z. So, what will happen if delta R, that change in position, change over time? What can we get? If the change in position change over time?
The velocity.
And that is not derivative. This is difference. But if there is a change in position, right? So what do you get when you get the change in position? If we go to 1 dimension, what we get when we average velocity. This will be average velocity in 2 dimensions or 3 dimensions. So what will be? Delta R over delta T, but because will be delta X, which is this, divided by delta T, I, plus delta Y, divided by delta T, J, plus delta Z, divided by delta T, K. So, in other words, V average will be the same than V average along X, which which is V average along xi, plus V average along y, j, plus V average along z, k. This is the average velocity. Same thing. You can work simultaneously or you can work independently, which is I suggest to work independently. Like you treat the x-axis, the y, and the z independently. So you will use the same equation we learned here, but along x. Then the same equation along y and so on. Now, what will happen if we get, instead of this, the tangent line, which is the derivative? We get the instantaneous velocity. Instantaneous velocity is the derivative of dr over dt, same thing. So will be the derivative with respect to x, I, the derivative with respect to y, j, the derivative with respect to z, k, which is the same than the velocity along x, I. Now we discriminate along y, j, and along z, k. This is the definition of velocity. Same thing that we had before, except that now we have to add the 3 dimension. Same for acceleration. What will be the definition of acceleration average in 3 dimensions? Will be, according to what we learned, is the change in velocity over time interval, but along x, I, plus delta v along y over delta t, j, plus delta v along z over delta t, k. This is the average acceleration. It's a vector. For the reason all these are vectors, since all these are vector, we need to get in 2 dimensions the ijk notation. If I ask for the magnitude of the vector, magnitude of the velocity, magnitude of the acceleration, average, or whatever, instantaneous, you get the square root of this square plus this square plus this square, which was what we learned in vector analysis. So they are vector, and if you need to add it, you can add it. If you need to multiply by a scalar, you multiply by a scalar. If you can multiply 2 vectors, you can multiply 2 vectors. Same thing that we did with vector in 3 dimensions. So if I ask for the magnitude of, let's say, the v instantaneous, which is this, you find the square root of vx squared plus vy squared plus vc squared. That will be your magnitude. Any questions so far? Good. And if the acceleration is constant, can be constant along x, but not constant along y, or not constant along z. But if in 1 dimension is constant, or in the 3 dimension is constant, you will use the same equation. Position change with the time as RO plus BOT, which all these are vector, plus 1/2 8t squared, which is the same that if you put it like this, if it's along x, x will change like this, and this is a combination of the 3 equations, but along x, along y, along z, depending on in which direction is moving at constant acceleration. Again, you can treat this independently. So x can be this, y can be the other one, and so on. So xo plus bot plus 1/2 8t squared along x. Then vx the same, vxo plus bo plus a along xt, and so on. The 3 equations, depending on which direction. All right, this is basically the theory of motion in 2 or 3 dimensions. Then we will study a special case, which is projectile motion, the motion of a projectile, which is the same than free fall, but in 2 dimensions. All right, so to do problems on this, we go to questions. So for up to 22, I said 1 to 22 is motion in 1 dimension in the study guide. So if you get the study guide, we can go and we can look at the equations, how the equations are treated here on motion in 2 dimensions. So, for instance, let's do question, let's say 23. So 23, 24, 25 are examples of motion in 2 dimensions, on how to work with this equation. For example, so in 23, said at t equals 0, a particle leaves the origin. What tells you when the particle leaves the origin? So when we are dealing with this, if we are solving a problem, so it starts at what point? 0, 0, 0, right? If it's a 3 dimension. This, if we keep reading, you can see that it's moving in the XY plane. It's 2 or 3 dimensions? 2 dimensions. Because it's moving in the XY plane. So, at t equals 0, they said that that RO is 0, 0, 0. And because it's 2 dimensions, I don't have to write the 3rd dimension. So will be R0 is 0, 0. These are the coordinates when they said that started at the origin. Then, at the origin, leaves the origin with a velocity of 9 meters per second in the positive y direction. How did start the particle move? How they start moving? Like this, right? In the xy plane, but vertically. So, what is telling me? If it's at the moment, at the origin, how can I label that in my givens? Which one? Because if you look carefully, they said the initial velocity leaves the origin with a velocity of 9 meters per second in the positive y direction. So, the initial velocity, yes, it's true. The initial velocity, VO, is equal to what? 98. This is my VO, which is the same than VYO. So you can see that this is the same than VYO. And any question on that? Okay. Working, BYO, but it's a vector. Okay. Then, if we keep reading, said, and moves in the XY plane with a constant acceleration. The constant acceleration is A all the time. Is given by 2I minus 4J meter per second square.